Hey, I'm Melissa.
And I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life,
a podcast where we help you understand the chemistry of everyday life.
Today we're going to do a special episode that's kind of different, and we're going to do a Q&A. So we've got a lot of questions from the listeners, and we want to take some time to answer those questions.
Yes, and a lot of these mostly, some of them are general, but mostly regard like episodes 1 and 2. Mm-hmm. And so we wanted to go ahead and do this kind of soon so that those questions aren't sitting like unanswered for a long time, because we've already got other episodes coming down the way. So we might, if this goes well, might do more of these in the future, I think.
Yeah. So you guys should submit your questions if you have them so that we can answer them and possibly include them on a future episode. But before we do that, let's catch up, Jam. I haven't seen you.
Yeah, I think people are probably kind of confused when we say that because of how our recording schedule has been. But yeah, it's been some time. We've both been out of town. I had a pretty cool thing happen in my life. Yeah. My younger brother and his wife had their baby. They and she is beautiful. She's incredibly sweet, really, really cute little kid. Her name is Harmony Joy Robinson, and she is the first kid of our family, the first grandkid or whatever of our side of the family. So I've got nieces and nephews on my wife's side and love them to death. It is a little bit of a new deal having someone in my own, blood relative have a kid, especially because it's my younger brother. Yeah. So it's pretty interesting, but Em and I went to go visit them just really briefly, just to see them. We had a 3-day window. We were like, if we can do this now, it'd be great. We can see this little one before too long, and we're not sure how soon we could get back up there. Yeah. Be better to spend a little bit of time than no time at all. Yeah. And so we got to go up there and help them a little bit and just get to spend time. They definitely are in that new parent stage, which I just have heard about but never experienced myself, obviously. And you know how some babies aren't really cute from day one? Yeah. Like, it's not their fault. Nobody's fault.
They're cute in that they're a baby, but you're not like, oh.
Yeah, sometimes they have a little bit of that, like, okay, let's get some meat on those bones a little bit. Look a little bit alien.
Let's fatten you up a little.
but that is not at all how Harmony is. She's cute from day one. Really, she got chubby cheeks, just cute looks. She does a lot of stuff with her hands already, which maybe that's not weird, but she was like...
But you think it's amazing?
Yeah. And I was holding her at one point and she was putting her... I don't know what she was trying to do. Maybe she doesn't either. She was putting her hands by her face a lot. It just looked so
so cute.
Yeah, so cute. And she knew what she was doing. She was reacting to things that was going on. Yeah. Like putting her fist up to her cheek, and it seems like what you'd do if you were thinking. And it's what this little baby's thinking. So
I'm over here smiling like an idiot. I've seen pictures of Harmony. She is so cute. Mm-hmm. Can you put pictures of her on Instagram, the podcast?
I will ask.
Instagram?
I bet it'll be fine. I'll ask. But yeah, congrats to Judah and Mindy, and I'll ask so that you guys can all enjoy the cuteness of Harmony. So by the time you're listening to this, it might have already been approved, and you'll see photos of her, hopefully.
Yeah, hopefully so. Yeah, she is really cute. And just so everyone knows, Jam is over here smiling like an idiot. He's totally in love with this tiny baby.
I totally am.
Well, I was out of town too. I want to talk about my thing.
Yeah. Is your thing as cute as mine?
No, I was about to say it's not as cute. Okay. It's not nearly as cute.
That's okay. No one's comparing.
I think everyone's comparing.
Yeah.
I also went to see my sibling. Mm-hmm. I went to see my sister. She lives in Mississippi. We talked about her before.
Climate scientist.
Yes. She does sea level rise. And I had a week where I wasn't teaching, so I went to just basically get work done with her. And then my brother-in-law, who I didn't talk about last time, but he he wasn't there at the beginning of the week because he's a boat captain.
Whoa.
Which I think is really cool.
Captain is still a title you can have. That's that's cool.
I think technically on the boat he's on now, he's a first mate, but he has a captain's license. And he works on a research vessel. So I don't know if non-boat people know this. I wouldn't have known this without him, but there's boats for merchant ship, research vessel, just different boats that have different distinctions. He works on a research vessel. So labs that need to do some kind of research on the ocean or in the Gulf specifically can hire a research vessel to go out. And so he works on the Point Sur. He actually got me this cute t-shirt of the boat, and it has it on a picture of the boat on the back. And I'm like, this is where my brother-in-law works. It's so cool. And while we were there, we worked on his Instagram game.
Oh, nice.
Because he was like, look at all these cool pictures I took. And he showed me this dolphin, like these dolphins just like playing by the boat. He's got
probably awesome opportunities for really good Instagram stuff.
Yeah. And they had some NASA scientists on the boat, and they did a weather balloon that went off from the boat, and he just recorded that happening.
Yeah.
It's so cool. And there's sea turtles. I mean, he has so much cool stuff happen to him.
He's got to share that with the world.
Yes. He was just hoarding it on his iPhone.
Yeah.
And I was like, okay, well, it is a crime.
Yeah.
I forced him to up his Instagram game and post some of those really cool pictures so that everybody could see them.
Yeah.
So if you want to follow him on Instagram, you can go to JD on a boat.
JD on a boat? That's a good title.
His name is JD. So he's on a boat.
He should have put captain in it, but I like that it's just on a boat.
Well, I think it started before he was it started before he was a captain. So JD on a boat. So you can go and see his beautiful. He took a picture of the moon where you can see the craters in it so well. It's crazy.
There'd be a lot less light pollution out there. That's pretty cool.
Beautiful sunrises, beautiful sunsets. If you would not believe how beautiful the Gulf of Mexico can be.
It's like we only see the like kind of grungy, trashy part on the beach where like weird stuff washes up and there's like questionable stuff in the water, like sewage or whatever.
Yeah.
So
sewage, I don't know about, but it is beautiful. So that was fun to get to hang out with him and just have the weekends and evenings to do fun stuff with my family while still getting a lot of work done.
Yeah, that's awesome. Should we start digging in to these pretty intense questions?
I think so.
Okay. The first question we have from episode 1, this question's from Vianet. There is a soap plant that they use in Peru to clean things. It makes suds and everything. Does that have soap molecules in it?
Okay, so when we got this question from Vianet, I got really excited. And I whipped out my phone and looked up what the soap plant was. Now I don't remember what it was called because this was maybe about a week ago. And then once I found the name, I was able to look up the molecular structure of the thing that was in it that caused the suds. And it wasn't exactly the same as a type of soap molecules that we would see in our everyday chemistry textbooks. But it did have the same qualities of long nonpolar groups or big, they were rings, but big areas of nonpolarity with random areas of polarity on it. So it did have that same capability of bringing together the polar and the nonpolar and making
nice.
Things
so it looked
clean.
A little different, and it wasn't like the exact same elements that you said are most common in soap?
No, it was the same elements. It was a different arrangement.
Oh, okay. Got it. Man, that's crazy. So it's just a plant that just occurs naturally.
Yes.
So the idea of it being like something just on the earth or in the earth that can just already kind of be soap is not that crazy.
Not that crazy.
All
it's
right.
actually real. So good job, Vienna. Way to go to Peru and learn things.
Yeah, that's awesome. And this next one's from Steven. My biggest question from the episode: how are the polar and nonpolar parts of soap molecules connected if polar and nonpolar don't interact?
Okay, that's a good question. And I sort of touched on this, I think, in the episode, but you're sort of thinking about two different things. So one is a bond, and bonds can be polar or nonpolar, all on the same molecule. It doesn't matter. So you can have an area that's very polar on this molecule, and then, so it's carbons just bonded to hydrogens, which basically have the same electronegativity and are neutral. And then in the middle of that, the carbon can also be bonded to oxygen, and that would be a more polar bond. And that's okay to all have on one molecule. The things that don't interact are separate molecules. If you have a polar molecule and a nonpolar molecule, those two don't want to interact.
Okay.
So it's more about, one is called intermolecular forces, like between molecules, polar and nonpolar don't want to interact. Within the same molecule, it doesn't matter if the individual bonds are polar or nonpolar. You can have both present in one molecule, and that's not a big deal.
Okay. So it's not like the idea of polar and nonpolar, like seeming to be enemies or whatever, is not really a thing. Once it comes to the point where like they're part of the same molecule, they're not like I hate you, or
yeah,
whatever.
if they're in the same molecule, it's fine. They just only want to interact with other things that are like them.
Okay.
So once it's all in one molecule, it doesn't matter. But once think of the molecule as a body. If a body is one way, it would only want to be with other things like it. But on the body, there can be several different things.
Got it. Okay.
Okay, so.
Okay, the next questions are about episode 2.
Okay.
The first one is from Pedro, and he says, maybe I didn't listen, but is there such a thing as specific cold? Same as specific heat, but instead it applies to colder temperatures.
So the quick answer is no.
Mm-hmm.
Cold in science is really just the absence of heat.
Got it.
So really, no, there's not specific cold, but specific heat applies to gaining and losing temperatures.
Okay.
So gaining and losing heat will raise or lower your temperature.
Right.
So the short answer is no, but the real answer is no, but specific heat applies to everything.
Right. So like the second part of his question kind of about applying to colder temperatures, it's specific heat still measures that, right?
Yes.
So it's just the difference of in vocab, we use the words cold and heat as opposites, and it's like you'd want to have both or whatever. Mm-hmm. But in science, heat is like you're measuring it. If there's not any of it, it's cold, but you'd still use the word heat.
Right.
It's like there is or isn't certain amounts of heat. Okay.
Exactly. You got it.
That's a good question. Okay,
these are all really good questions. I was excited when I got every single one.
So this next one, two different people asked this question, Ryan and Grant. Why do different things have different specific heats? Uh-oh.
So we glossed over this in the episode.
Yeah.
Kind of purposefully because it's a little complicated, but I think I found a way to explain it that is quick and understandable.
Okay, awesome.
So different molecules have different ways they can move, like in and out or up and down. It's like rotational, translational. They can circle around. They have lots of different options for motion. Mm-hmm. The more options for motion they have, think of each option of motion as a little shelf where they can store energy.
Okay.
So the more options of motion they have, the more shelves where they can store energy is going to be. So you can take in more energy in the form of heat before your temperature is increasing.
Got it.
Because you have more places to store that heat.
Okay.
That's
interesting.
The best way I can think to describe it. So water, for example, has a lot of room to move. Mm-hmm. Ice, the same molecule, but in a different structure, has way less room to move because the molecules are rigidly put together.
Right.
And so ice actually has a lower specific heat than water does, even though they're the same molecule, because it's in a different state.
Totally. And that makes sense to us visually because we know that ice, like we don't think about it as having low specific heat, but we know that whenever it's experiencing heat, it can't just take that in and handle it. It melts. It's going to have to change its form, its state.
Right. So consistently solids have a lower specific heat than the liquids of the same substance.
Okay, got it. So shelves, they store the heat, or if they don't have room to store it, then it changes their temperature.
Right.
Got it.
That's a nice little bit of physical chemistry for you. That's a little deeper dive. Beyond Gen Chem, we got some physical chemistry in there.
Nice. Okay, this next question is from Steven, from the same Steven, right? From the previous. Okay.
He's had very good questions. Steven has had very good questions.
So he said, I have another question related to episode 2. I've been meaning to ask, is there any correlation between specific heat and melting and boiling points? E.g., does higher specific heat usually mean higher melting boiling point?
That is a really good question. So I alluded to this in the episode, but when I was researching this episode, I went down a physical chemistry rabbit hole. Uh-huh. And I started down this rabbit hole with my organic chemistry friends, which probably wasn't the best choice, but there were no available physical chemists around me at the time. So I went into an organic chemistry lab down the hall and I said, hang on. So different things have different specific heats. Is that as a result of the same forces that cause melting point, boiling point? those forces are known as intermolecular forces. They're basically the forces that hold different molecules together or keep them further apart. They're responsible for a lot of things. And we were just chatting about it, and everybody seemed to think, yeah, that makes sense. Yeah, probably so. And then I went back to my office to keep working on the episode, and then I thought, wait a second. That doesn't make sense because sand is not melted and water is.
Yeah.
And so it can't be as a result of the same forces.
Yeah.
And then I went back and asked that question to them, and they all said, oh, yeah. So that is a really good intuition, Stephen, and a good thought process. But actually, the answer is maybe that has a little bit to do with it, but mostly it's what we talked about before with the things of motion rather than the intermolecular forces that hold them closer together or further apart. That is a little bit involved because the rigidity comes into play with the way the molecules are interacting with each other, but it's more about how much motion they have and less about breaking those forces between one another.
Yeah. And then the case of like sand and water, it's almost like the opposite is true. It's like inverse because it's like, water has a lower melting point, obviously, because it's already water. Right. But it has it has to get a pretty hot to boil. And the sand is like we talked about, experiencing the same heat source being put on it. Right. And it's staying in its same state. So it's like, it's almost the opposite is true, where it's like, like the sand is having a much stronger reaction in terms of what we feel when we touch it, even though it's staying solid and not melting. Right. It's weird.
So they feel like they would be as a result of the same thing because they both have to do with putting heat into a substance, but it is actually very different things that dictate it.
And I'm definitely thankful that's the case because I don't want to be walking on like, liquid lava glass stuff when we go to the beach. So
yeah, that's probably better for you.
Yeah. The beach would be like a very, very different place if that was not the case. Okay. What is the typical life cycle of an episode?
So I know the first half of this question, but you're going to have to answer the second half.
Okay.
The typical lifestyle starts with me having an idea. So next week's episode, I got the idea when I was sitting watching my brother-in-law cook a meal, and I saw him do something, and I was like, oh, I know why people do that. But do people know why they do that? Yeah. Or we have a long list of topics that we want to cover that I've just been thinking of and compiling. So I just pick a topic and basically put together an outline. And I usually know, so far, I haven't had to learn a ton, but I will fact check. I'm like, I'm pretty sure it's this, but I just don't want to teach anyone the wrong thing. So I'll go quick, grab my chemistry book or whatever, and just like do a quick review and make sure that what I'm teaching is accurate.
So just sort of like pre-fact checking.
Yeah, to make sure that I sort of know that this is based in science and not. Yeah. Sometimes people just teach you things in classes and then you can't find proof of that anywhere. Yeah. You just wonder, is that real?
They're just passed down from like audibly from person to person.
Right. Yeah. So I'll go fact check, and then I have that outline that I've put together, and I just know what I'm going to say. And I come in, and Jim has no idea usually what I'm going to say. Yep. I might give him a little bit of a teaser or tell him the name of the topic, but everything he learns, everything you hear of him saying, oh, or asking questions, that's genuine. That happens in real time. And so we'll come and we'll have our conversation, and I'll teach him whatever I'm teaching him and also teach you guys. And then
one question even I got about people not realizing that I'm learning it for the first time also. We try to make that live so that it is genuine, and also it's like a really good test for if this is how learnable something is. Like if I totally failed at learning it, it'd mean either like I'm a bad learner or we need to explain it differently or something. So I'm like totally unprepared, don't have like there's no cheating that happens or anything like that. I think it is best for both of us for Melissa to know that I already don't know it, so she has to teach it from square one, and for me not to have any prior knowledge other than just something from my life or something I might remember from a chemistry class forever ago. Yeah. And it makes it a much better environment for teaching for listeners as well.
Yeah, and that helps me to know what I'm supposed to, or how I can explain it in a way that's helpful. And sometimes there's things that I think I'm explaining really clearly, and then Jam has questions, and I'm sort of, my response is, oh, I need to think of another way to explain that. And that's probably true not only for Jam, but also for the listener. So it really is helpful to make sure that you listeners are getting the best experience possible.
Yeah.
But then after that, I don't really know what happens to episodes.
Yeah.
I come here and I record, and then I say, bye, Jam. I'm going off to school now, and leave him to it.
Yeah, it's probably kind of boring, so I'm not going to go into crazy detail, but I listen back to them and clean up stuff like coughs, or if we had to like restart a sentence, or if there was a weird sound, or like I knocked something off the table, or
the dogs like to chime in.
Yeah, or a dog sound or whatever. Just clean them up a little bit. And adjust levels and some EQ stuff, and then then export that and send it to Melissa to listen to and make sure that she hears it back and doesn't hear anything that's factually wrong or confusing. So we kind of have a double check there. And then we have some friends that have volunteered to be reviewers, and so they help us out, and you'll hear them as credited at the end of episodes. And so we get that feedback from them. If there's any additional edits, we make those. And then we schedule them to be sent to your ears.
Yeah.
On our host. So.
Yeah, and that's fun because you can see all the analytics and stuff.
And so that's my, I guess, half of it. But
it seems pretty evenly distributed of who does what.
Yeah. The next question that came from Stephen is Jam your real name, and why do you go by Jam?
Well, and that didn't just come from Stephen. That came from a lot of people have asked me, who's Jam? Is that his real name? Why does he go by Jam? So, Jam.
Okay, so my name is Joshua Andrew Miguel Robinson. So Jam is my initials, or Jam with an R is my initials, I guess, the full thing.
Jammer.
I don't go by Jam to everyone, but the name Josh or Joshua is really common, and I don't like it. And so it's not like I get to choose what everybody calls me, but when I was in school doing film projects and everything like that, I needed to have something that was a unique name to attach to all of my work. And so I started doing J.A.M. Robinson, like you'd see for a lot of things like authors, or like J.R.R. Tolkien is the best example I can think of because he had also two middle names. So I started putting that on my projects, not really thinking about it, but people would just read it as Jam Robinson instead of saying J.A.M. Robinson. And so a few people called me that, and then on a professional level, that's what I go by almost exclusively with work and stuff. So it helps too because it makes me unique in terms of searchability for projects I do, or website stuff, or LinkedIn, or resume stuff. It just makes, you'd be surprised at how many Joshua Robinsons there are. So that's kind of the explanation. Does that make sense?
That does make sense. So if I was walking up to you on the street and I know you and recognize you, you would want me to say, hey, Jam, or hey, Josh, or hey, Joshua.
Yeah, Josh is my least favorite of all of those.
Okay.
But it's also the one that probably like the most people call, because most people who are named Joshua are like totally cool with being called Josh. And so it's kind of like a copy paste deal. But I'm not going to correct people about it. It's just not worth it.
Okay.
Just too much effort. But yeah.
So now everyone knows. So if anyone asks me that, I'm going to say tune in to episode 5 and you'll get your answer.
Yeah.
Perfect.
It's probably not that satisfying either, though, because it's not like there's no big, I don't know.
I think it's interesting that your name is Joshua Andrew Miguel is interesting.
That's true. That is pretty, people wouldn't guess that. So, yeah.
Okay, so is that all the questions that we have?
That is it. That's all the questions. Thank you guys so much for sending those in.
This is a little bit of a lighter episode if you needed a break from the intense chemistry learning sessions.
Melissa and I have a lot of ideas for topics of chemistry of everyday life, but we want to hear from you. And if you have any questions or ideas, you can reach out to us at Gmail or on Twitter, Instagram, and Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share thoughts and ideas. And if you enjoyed this podcast, you can subscribe on your favorite podcast app. And if you really like it, you can write us a review on Apple Podcasts. That helps us to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. Jam Robinson is our producer, and we'd like to give a special thanks to Autumn Kiwasong, who reviewed this episode.